Hi guys, welcome to Unit 13. This unit's going to be broken up into two sections. In this first video we're just going to be talking about the first section, which are just the body fluids. So what body fluids are, what fluids do we have in our body, and why are they important? So we break down body fluids into two categories. We have the intracellular fluids. This is the stuff that we have inside of the cells. Okay, so anything that's fluid inside the cells, the cytoplasm for example, that's intracellular. And that's going to be about 40% of your body weight, so it's a significant amount. And then we have the extracellular, which of course is going to be anything that's outside of cells. So that's going to be the blood plasma, the lymph, specialized fluids like our cerebrospinal fluid, and the interstitial fluid, which is the tissue, the fluid that kind of hangs out in between cells within a tissue. And if we put all that together, that's going to make up about 20% of your body weight. Now, we are dependent on water for almost every chemical reaction that happens in our body. So our balance of hydration, how much water is in our balance at any given time, is crucial. It's super important. Now, when we talk about balance of water, there's four real systems and particular sets of organs that are important with maintaining an adequate amount of water or getting rid of excess water. And that'll include, first and foremost, the kidneys. They're super important in maintaining balance. They'll excrete the largest amount of the largest quantity of water each day through our urine. Next, we have the integumentary system. Of course, our skin. When we sweat, you guys know we lose water through evaporation. And being a land animal, we're constantly in a battle against evaporation or loss of water across the skin. So that's a super crucial organ, our system right there. The respiratory system, we've talked about how when we breathe, we need to have moist surfaces for those gases to diffuse. And therefore, every time we breathe out, we are losing moisture content. So that's something else we need to be very careful about. And then the digestive system. Of course, as we're digesting things, we use water. We need water, and we try our best to reabsorb as much water as we can before we excrete anything so that we can maintain water balance and keep as much water as possible. Now, water intake, we obviously need to drink water every day. Water is crucial. You can survive without food for long periods of time. You can't survive without water for much more than a couple of days. In order to maintain these balances, we need to have a high control of regulation of what happens with water in our body. Thirst, for example, how much water we drink, that's controlled by the hypothalamus. We've got osmoreceptors, so these are going to be sensory impulses, sensory nerves that will monitor changes in sodium levels in our body, and that will let the body know if we need to increase or decrease our water intake. So if you're feeling thirsty, there's a good chance that somewhere in your body there's osmoreceptors that are saying, we've got a little bit too much sodium here, we need to have some water to help reduce the concentration. Now, in cases of excessive water loss or intake, the body will adjust the thirst to suit that level. If you need more and more water, you're going to feel more and more thirsty. If you have lots of water and water is abundant in your body at the time, you won't feel thirsty at all. So this is a way that we kind of control how much intake we get. A super important part of water balance is electrolytes. So electrolytes are very important constituent, so a very important part of our body fluids. And electrolytes are simply positively and negatively charged ions. We've got a couple of principal ions that we'll look at here. The cations, of course, are ones that are going to have a positive charge. So sodium, potassium, and calcium, these are super important cations. Sodium is going to be chiefly responsible, so this is going to be the main one that the body looks at in order to maintain osmotic balance and the body fluid volume. Okay, so we got to keep our body within that hypotonic or hypertonic range. Isotonic is ideally where we want to be, and we also need to have a certain volume of fluids in our body, so we need to make sure we're adjusting based on that. Potassium is super important when we're talking about nerve transmission. We didn't go into detail about that in this course, but potassium is a crucial electrolyte when it comes to the nervous system. Calcium, of course, is going to be required for bone formation, blood clotting, muscle contraction, and as well nerve impulse transmission. So this is a super important ion. It needs to be well regulated. Now the anions, these are going to be the ones that have the negative charge. We're going to be looking at phosphate and as well as chloride. So these are going to be the negative ones, and cations are going to be the positive ones. So for phosphate, again, it's going to be another element that's really important in bone formation, and it's also present in our nucleic acids, so we need that element in abundance. And the last anion is chloride. Now chloride is going to aid in the balance of body fluid balance, and it also helps in the formation of hydrochloric acid, which we find in the stomach. So that's going to be a super important one for digestion, activation of pepsin in the stomach. So electrolyte balance is going to be super important. We need to make sure that we have those ions available to us when we need them for our different metabolic functions. So electrolytes are present in both the intracellular and the extracellular fluids. So we have them in abundance inside of our cells when our cells need them, and we also have them on the outside of the cells in case they're needed out there. But maintaining that balance, maintaining access to them is really, really important. Most of the time we control this electrolyte balance through the kidneys, and we're going to talk about the kidney function in the second part of this unit. But there's also a hormonal component to it. Okay, you're going to have hormones like aldosterone, for example. Think back to what gland produces aldosterone, and aldosterone is going to be important because it'll help reabsorb sodium, and it'll also it helps promote the elimination of potassium. So one hormone can control two different electrolytes in opposite ways. So an aldosterone is a really particularly important hormone when we're talking about electrolyte balance. That's the one I kind of want you to focus on. These down here are just kind of more examples of different hormones that help control different electrolytes. So we've got the atrial natriuretic peptide, and that's going to cause the kidneys to excrete sodium and water. So that can control not only electrolyte concentrations, but it can also control fluid volume. Hormones from the parathyroid and the thyroid will help regulate calcium and phosphate, and we talked about those are two really important electrolytes. So we also have aldosterone is going to be the principal one we'll talk about, but we'll also I want you to keep in mind there's more than one hormone that's working when we're talking about electrolyte balance. So here's an example of how aldosterone in particular helps with two different conditions. So these are kind of two graphs. We've got a left and a right side. So this side here, we're talking about blood pressure, and on this side over here, we're talking about concentrations of potassium. So this is an example of how aldosterone does a couple of things at once. So if we just look at the left side first, what can happen is if our blood pressure gets a bit low, aldosterone will be secreted, and that'll cause us to increase sodium at the kidneys. When we do that, what we'll do by osmosis is we'll increase the amount of water we keep in our body, and by having excess water, then that's going to increase our blood pressure. So that's an example of a negative feedback loop where we go from low blood pressure, we get secretion of a hormone, we get the effect in the kidneys, and then that effect will basically turn off the aldosterone secretion because we returned our blood pressure to normal. So that's a really interesting case of how aldosterone can work to help regulate blood pressure by looking after our fluid composition and electrolyte balance. If we look at the other side of the graph, now we're looking at a situation where we have high concentrations of potassium. Now when aldosterone is secreted in this case, we will secrete potassium, which means we'll lose calcium from the interstitial fluid, from the body fluid through the kidneys in the urine. So we'll be getting rid of excess urine through excess potassium through urination, and that's going to lower the blood potassium concentration. So again, negative feedback loop. We've lowered the blood potassium concentration, then that will fix the problem, and it'll turn off the secretion of aldosterone. So that's an example of just how one hormone can regulate a bunch of different things, and it can affect a couple of different processes in our body, from low blood pressure to electrolyte composition. Another thing that we need to be very careful about in our body is pH. We need to have our pH within a very certain range, and that's because we need to keep our enzymes happy to carry out our metabolic reactions. One thing that happens in our metabolic reactions, though, is we constantly produce acid. Just simple equations like glycolysis, for example, is going to produce a ton of pyruvic acid. If we exercise a lot, our muscles are going to go into anaerobiosis, and that's going to produce lactic acid. Carbonic acid is produced whenever we have carbon dioxide in a solution. So we're always pushing our bodies, and our bodies are always going to produce acid. As a result, it's going to end up lowering our pH, which isn't good. So we need a way to control that. One way that we have is our buffer systems. Within our body, we have substances that are present that will help prevent these sharp changes in pH. They'll be looking at adjusting changes in the hydrogen ion. I mean, if you guys have studied acids, bases, chemistry, you know the hydrogen ion is what gives us our pH changes. So our buffer substances will help if we have any of these big changes in hydrogen ions, so that we don't get these changes in pH. The main buffers that we're talking about in the human body are going to be bicarbonate, phosphate, and there's going to be proteins as well that help regulate pH. Another way that we help regulate acid-base balance is by respiration. Changes in respiration, of course, are going to increase or decrease the amount of carbon dioxide that are in the blood. So for short-term changes, we can change pH of the blood just by changing our rate of respiration. And then the last one there is the kidney function. The kidney is, of course, going to be responsible for much longer-term changes in pH. So by either the absorption or the secretion of hydrogen ions, we can change the pH of the body just by what ions we lose in our urine through our kidneys. So two conditions that can result from this are acidosis and alkalosis. If you look at this, one thing that I kind of want you guys to pay attention to is when we're talking about these, we're talking about a very, very low range. So ideally we want to have our blood pH somewhere in between 7.35 and 7.45. Anything lower than that, then we get into a condition called acidosis. And acidosis is when we have our blood pH is below 7.35, and that's going to disrupt regular metabolism. So we can get this through metabolic ways. So if we're not breaking down enough carbohydrate, for example, if we have prolonged diarrhea, so we lose a lot of fluids, or if we start to have kidney failure, this can all result in acidosis, so the blood pH becoming too acid or too low. Another way we can do this is by respiration, hypoventilation. When we're not breathing enough, carbon dioxide will build up in the blood, and as a result, that'll lower the pH of the blood. Now, the opposite condition would be alkalosis, and that's when the pH goes above 7.45. The way this can happen metabolically is, of course, if we ingest large quantities of antacids. So if you take Rolaids or Tums or something like that in order to prevent stomach acid. If you have prolonged vomiting, for example, will remove so much acid in the body. As a result, the pH will go up, become a bit basic, and we'll have this condition called alkalosis. Respiratory, in terms of how that works, if we hyperventilate, we're breathing in, getting rid of an extra amount of carbon dioxide, and that'll cause our blood to go a little bit basic, and that'll switch us into this alkalosis. Some of these diffusions of the body fluids, I only kind of want you guys to pay attention to a couple of these. The first one is edema, and that's when we get an accumulation of body fluids in the extracellular spaces. So we get areas where we've got fluids where we shouldn't have any. So edema, we've seen that in, we usually can see it in a lot of places. I know mountain climbers suffer from edema. Fluid builds up, leaks out from their tissues, and gets into their brains, and it can cause them to get pretty sick. We can also see this in acute cardiac patients. So edema is something that they need to watch out for. The other ones are here. You can have a look at them. The other one that I want you guys to focus on is dehydration. Okay, whenever we have a severe deficit of fluid, we call that dehydration. It can happen a lot easier than you think, and it's a very, very serious condition. Okay, could lead to death.